All right, let's work through number 31 here, a popular question that a lot of people have asked about. So the first thing we want to be able to do is actually read this question and determine what the question is asking us to do. So we've got to look carefully at the words. So we want to write a formula for the volume of a cone in terms of the circumference of its base. Okay, so I'm going to stop there and see if we can unpack what that just said. So when it says write the formula for the volume of a cone, that means essentially that we want a formula that will help us calculate the volume of a cone. Okay, so it should be V equals volume equals something. Now what's going to be on the other side of that equation? Well, there's more than one way to write the formula of a cone. The usual one has the radius in it as its variable. So we want the formula for the volume of a cone to be written in terms of the circumference of its base. In other words, the variable that shows up in our volume formula is C for the circumference. So the volume formula is going to have C as its variable, along with some other numbers, depending on how I have to calculate it. But the formula is for volume, so V equals, and it is written in terms of the circumference. So the variable in that equation should be the variable C for circumference. So we've got to make that happen somehow. And let's start with the formula for the volume of a cone, the one that you must know cold. So the volume of so a cone is like a pyramid. The volume of any pyramid is the area of its base times its height divided by 3. Now here, the area of the base, capital B, of a cone is a circle, so it's pi r squared. So pi r squared times h divided by 3. So this is the formula for the volume written in terms of the radius and the height. So when it says written in terms of, that's telling you what the variables are that are used in the formula. We want to write it in terms of circumference, so that means we need some way to replace or substitute this r with something that has c's in it, and same thing with this h. So do we have any sort of relationship between c, the circumference, and r, the radius, that we can use here? Sure we do. We have the circumference formula. So the circumference formula for a circle, we want to use the version of the circumference formula that has the variable we're trying to replace, r. Okay, so c equals 2 pi times the radius. There's the variable we're trying to replace in our formula, the r, and here's the variable that we want to show up in the formula, c. So what we need to do with substitution is solve this equation for the variable we're trying to replace, which is r. We're going to get r by itself. To do that, because it's multiplied by 2 pi, we need to divide both sides by 2 pi. So c divided by 2 pi is going to equal r. And now we can take this and we can substitute this in for r. So we're going to substitute that. So in other words, our volume formula is going to equal pi, and then we're going to replace r with c over 2 pi. And it's still going to be squared because r was squared. Okay. Now we need to replace this h with something that has a c in it as well. So is there some circumference formula that has the height of a cone in it? Something like that? No. But we do know something about the height. So let's read this. So the cone has a height that is twice the radius. Or in other words, h equals, the height equals 2 times the radius. Now, does that give me a way to write the height in terms of the circumference? Well, maybe. Right now we have the height written in terms of the radius. So how do we get the circumference into this height formula so that we can do substitution? Well, the way we do that is with actually another step of substitution. So we already know that the radius can be written in terms of the circumference as c over 2 pi. So we're going to make another substitution into this equation right here. So the height must be equal to 2 times the radius, which is c over 2 pi. So now what we've done is we've written the height in terms of the circumference. That means we should be able to make a substitution back into this formula. But first, let's see if we can reduce this a little bit. So those 2's would cancel, a 2 on the top, a 2 on the bottom. So then the height is just c divided by pi. And we're going to come back and plug that in for h. So we're substituting the c over pi in for h. So here's a volume formula that has c as its only variable after I replace that h that I just wrote, which was supposed to be c over pi, right there. So c over pi. Okay, so the only variable is c. In other words, this is the volume formula written in terms of the circumference, c. Now, we can simplify this somewhat. First, we should take care of this exponent. So what would c over 2 pi squared be? Well, remember, squaring something means you multiply it by itself. So c over 2 pi squared would be c over 2 pi multiplied by itself. Or in other words, multiply straight across, that's c squared. So there's my pi. So that's c squared over, and then 2 pi times 2 pi would be 2 times 2 is 4, pi times pi, pi squared. So 4 pi squared. And then I'll bring down this fraction right here. Now, something that's going to make this a little bit easier to simplify. Notice here I wrote the volume formula as pi r squared h divided by 3. And sometimes we've also written it as pi r squared h times 1/3, or 1/3 pi r squared h. Dividing by 3 is the same thing as multiplying by 1/3. So I'm going to write that as 1/3 instead of division by 3, just to make all these fractions line up a little bit easier, to make this simplification go more smoothly. And likewise, I'm going to make this pi into a fraction too. Pi is pi divided by 1. Now I've just got a bunch of fractions that are all lined up. I can see if anything reduces. So do I have any matching factors on the top and the bottom? Well, I've got a pi on top here and a pi on bottom there. Those can reduce. So now if I don't have anything else that can reduce, I don't think I do, then I'm going to multiply straight across on top. So c, this is a 1 now. This is a 1. So 1 times c squared times c times 1. So on top we have c cubed. And then 1 times 4 pi squared times 3. So here the 3 and the 4 will multiply together to give 12. And then we have pi squared also on the bottom. So in other words, the volume can be calculated based on the circumference, like so. So this is a formula for the volume in terms of the circumference.